Okay, in lesson 2, we're working with like fractions. First one was done forced. So the second problem says 1/4 plus 1/4 plus 1/4 plus 1/4. I'm going to develop my number line, and I'm going to leave enough for growth in case I need it. We know this is 0 and this is 1. And then fourths, since it's an even number, I know I can go halves and then quarters. And I know this is 0/4, 1/4, 2/4, 3/4, and 4/4. Now showing it on a number line, I'm taking 1/4 plus 1/4 plus 1/4 plus 1/4. And we can see our answer is 4/4. Now in the class, we were taking this a little further, and we were showing it as a multiplication. And now, since I have 4 plus 1/4 plus 1/4 plus 1/4 plus 1/4, we could also show that as 4 times 1/4, which would equal 4/4. And I could also turn this around to 1 times 4/4, which would equal 4/4. Our next one, we're going to do the same thing with our number line. This time we have sevenths, so I know I'm going to have 6 in between. There's 1, 2, 3, 4, 5, and 6. And this is our 1, our 0, and this is 0 sevenths, 1 seventh, 2 sevenths, 3 sevenths, 4 sevenths, 5 sevenths, 6 sevenths, and 7 sevenths being our whole. Now, this goes with 2 sevenths plus 2 sevenths plus 2 sevenths. And we can see that equals 6 sevenths. Now with this one, we could go 3 times 2 sevenths, since it's repeated addition, in order to show in multiplication sentence. And if I wanted to extend this, I could also go 2 times 2 sevenths plus 2 sevenths. There are just various ways. In the class today, we're maneuvering back and forth, showing how we can make different expressions. Okay, the next one, we're going to do our number line. And I can see this is fifths, so it's going to be 1, 2, 3, 4 in between them. There's our 0 and our whole. 0 fifths, 1 fifth, 2 fifths, 3 fifths, 4 fifths, and 5 fifths. It says 2 times 3 fifths, so that means actually 3 fifths plus 3 fifths. So we're going to go 3 fifths plus, if I go to make another 3 fifths, there's only 2 left. So I end up having to make another whole out here of 2. And we know there's 1, 2, 3, 4, 5. And counting down below, we got 5 fifths. That means it would be 6 fifths, 7 fifths, 8 fifths, 9 fifths, and 10 fifths. So coming back to our addition problem, we can now see we have 3 more fifths, and then plus 1 fifth, giving us 7 fifths. Now on this one, we can see 7 fifths, if we look at our number line, is actually also equal to 1 and 2 fifths. Because this is our 1, and then there's 1, 2 fifths after that. Okay, number 2, express each fraction as a sum of 2 or 3 fractional parts. We write this as a multiplication equation. Now there's many different ways you could do this. So this one here, since it's even, I'm just going to go 2 elevenths plus 2 elevenths plus 2 elevenths. And I can rewrite that as 3 times 2 elevenths. On B, we have 9 fourths, so I can go 3 fourths plus 3 fourths plus 3 fourths. And I can write that as 3 times 3 fourths. Now there's various multiplication sentences and addition sentences you can put together. I'm just putting together the ones that I can make groups of 3 out of. Now 12 eighths, I'm going to go with 4 eighths plus 4 eighths plus 4 eighths. And that would give me 12 eighths. And I could also go 3 times 4 eighths. Just to show you, we could have also done 6 eighths plus 6 eighths, and that would give me 2 times 6 eighths. So it just depends on how you're wanting to break it apart. 27, well, I know 9 tenths plus 9 tenths, that's 10, plus 9 tenths is going to equal to 27 tenths. So I could also do 3 times 9 tenths. Expressing the following is a sum of a whole number and a fraction. Okay? Well, when I do these, I like to take the whole out. So I know 5/5 plus 4/5. And that means that would be 1 and 4/5. So what I'm doing is I'm pulling the whole out of that number. Whatever is left is my fraction. Over here, on 7 halves, I know that'd be 2 halves plus 2 halves plus 2 halves. And that is going to give me 6 halves. So I have to have one more half for 7. So I know this is 1 whole plus 1 whole plus 1 whole plus 1 half. So that equals 3 and 1 half. On this one, I'm going to go 7 sevenths plus 7 sevenths plus 7 sevenths. And I know 3 times 7 is 21, so there's going to be 4 sevenths left over. And this is 1 plus 1 whole, 1 whole plus 1 whole plus 4 sevenths, so that equals 3 and 4 sevenths. Last one here, I go 9 ninths plus 9 ninths. And I know 9 ninths and 9 ninths would be 18 ninths. And that means I'm going to have 3 ninths left over. So that equals 1 plus 1 plus 3 ninths. So that would be 2 and 3 ninths. Natalie sawed 5 boards of equal length to make a stool. Each was 9/10 of a meter long. What was the total length of the board she sawed? Express your answer as a sum of the whole number and the remaining fractions. Draw a number line to represent the problem. Okay. So here's my number line. And there's 0 and a 1. And it says 9/10, so I know it's in tenths. So I know that's going to be 5/10. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is our whole right here. So this is going to be 0/10, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10 for a whole. Now it says he sawed 5 boards of equal length. Each was 9/10 of a meter long. Okay, so here I have 9/10. That's 1 board. So that means I would have to keep extending out here 5 more times. Okay. So as you can see, if that is 1 board, we know we have 9/10 plus 9/10 plus 9/10 plus 9/10 plus 9/10. There's my 5 boards. And we know that would also be equal to 5 times 9/10. Now they want to know what the total length of the board was. Well, you see if I skip counted, I got 9, 18, 27, 36, 45. So this would equal 45/10. And you can see up here also, 5 times 9/10 would be 45/10. So it works out. Now I know this 45 tenths would be 10 tenths plus 10 tenths plus 10 tenths plus 10 tenths plus 5 tenths. That'd be 1 plus 1 plus 1 plus 1 plus 5 tenths. So now we can see that'd be 1, 2, 3, 4, 4 and 5 tenths meters long. That's how long the total length would be.